All right, we're looking at physics principle numeric response scenario number 4. This is a question that I made up, not phrased exactly the way that a diploma exam numeric response question would be phrased, but it gives us the gist of it. Nice little example of some content that we could see on a diploma exam, and a little bit of practice for those physics principles that we have to list and the last two questions of our diploma exam. This one says, an electron is released at a speed of 6 times 10 to the 5 meters per second to the right in a uniform electric field of strength 200 volts per meter shown in the diagram. How far from its entry point does the electron hit the bottom plate? What are the two physics principles used? So we're looking for this distance right here, the distance from where the electron enters the two parallel plates to where it strikes that bottom plate. And then we're looking for those two physics principles used. This top plate should be labeled as negative, and this bottom plate should be labeled as positive. Not that it really matters when we're answering this question, but to be complete, really, we should label those two plates negative and positive. That should have been given to you in the question. All right, what do we do to solve this question here? First, we're looking at the electric field as pointing upwards, away from the positive toward the negative. And that makes sense even if those points weren't labeled. The electron is pulled downwards, so the electric force must be downward. The electric force must be opposite to the field because it's an electron, a negatively charged particle. The force is with the field if it's positive. The force is opposite to the field if it's negative. So there's one force acting and it's downward. This electron is moving initially horizontal, and then it's moving this combination of horizontal and vertical motion. It's a parabola, is what it is. The horizontal motion is not affected by that electric force. The vertical motion is affected by that electric force. So we've got two problems here. The horizontal motion, which is uniform motion, constant velocity, because it's not speeding up or slowing down horizontally. How would it be if there's no forces horizontally? Then we've got the vertical motion that is accelerated motion because there is a vertical force. When we have a vertical force, there's a vertical acceleration. So we have two problems here, an x problem and there's a y problem. We're looking for this variable right here, the x displacement. How far does this electron go horizontally? All right, let's sub in some numbers here and see what we can get. We have a speed horizontal of 6 times 10 to the 5 meters per second. And where initial velocity here is all horizontally, and it is 6 times 10 to the 5 meters per second. The horizontal displacement, we don't know. That's what we're trying to find. We don't know the time either. So that's okay. We'll just move on to the y component here and sub in some numbers there. The y displacement would be 15 centimeters. It ends up 15 centimeters below where it started. Let's put that in meters. Now we could put that as negative 0.15 meters, but we'll just define down as positive here. Makes it a little bit easier. The initial y velocity is 0. That 6 times 10 to the 5 is all horizontal. So we're just going to scratch out that term. The acceleration, we don't know. This, in physics 20, this would have been 9.81, but our force was a gravity force. This is an electric force, so our acceleration is due to electricity as opposed to gravity. We know in physics 30, when we're looking for an acceleration, we can almost always say A is equal to F over M. We don't know the force, but we can get it. We know it's an electric force, Q times E. Let's sub in some numbers there. The charge of the electron times the electric field strength gives me an electric force of 3.2 times 10 to the negative 17 newtons. Now that I have the force, we can divide that force by the mass of the electron. And that's going to give us an acceleration of 3.512623 times 10 to the 13 meters per second squared. So let's sub that in here is in place of, this is a physics 20 problem, it would be 9.81. We'll sub it in place of that 9.81, that physics 20, 9.81. Now what we're going to do is times a half by 3.51, and then take that over to the other side by dividing, and then we're going to square root it. And that gives us a time of 9.24155 times 10 to the negative 8 seconds, which will in turn sub in there. It takes 9.24 times 10 to the negative 8 seconds to travel vertically 15 centimeters. So it also takes 9.24 times 10 to the negative 8 seconds to travel horizontally the distance that it takes to hit the plate. So let's sub that in. Solve for delta D for the x component, and we're going to get 0.0554 meters. So 5.54 times 10 to the negative 2 meters. This should have said the format that you were to express this in, but this would likely be an A decimal BC times 10 to the negative D question. So we bubble that in as 5542. Now, our two physics principles. This is constant velocity or uniform motion, and this is accelerated motion, principle number 1. So we would bubble in those two physics principles as, which one did we do first? Doesn't really matter which one we did first. Which one did we do last? The one that got us the answer was principle 0, so we'll bubble that in second. And the one that we did, the other one that we did, was principle 1. So we bubble in 1, 0, and then we leave those last two boxes blank. So there's our answer, 2 points. Last two questions on the exam, most likely. 5542 for the answer for the question, and then 1, 0 for the physics principles. You can see how in this question, even if you couldn't get this one, even if you couldn't get this answer, and that's tough, you did stand a fighting chance. If you didn't give up on it, you did stand a fighting chance at getting the physics principles, right? Even if we can't do the math or figure out what the acceleration is or figure out the electric force, we do at some level know that this is two problems, a horizontal uniform motion and a vertical accelerated motion. So don't give up on it. Even if you can't get this answer, do your best to still get the two physics principles and at least get 1 out of 2 on that pair of questions.